Welcome to this first demonstration in landscape and habitat dynamics. I hope you've been able to access your Blackboard website and downloaded the course material, which is located in the mod 1 zip file, and downloaded and unzipped that onto your computer. So let's go ahead and add the data that's located in that folder, mod 1. And I can just grab the data layers I need. I'm going to grab lakes, states, streams, herd boundary, not that one, NED, DEM, and NLCD, and these layers are listed in your lab document. I'm being asked if I want to build pyramids, and I'm going to say no. Pyramids help display large data sets quicker, but these data sets are not very big, so I'm not going to use the pyramids. So here is the data kind of raining down here in ArcGIS. I'm going to click on this one to look at the layers. Let's just look through these real quick. We have a stream data layer. I'm going to turn them off as I talk about them. We have the herd boundary layer. We could zoom to that. That's the herd boundary for the bighorn sheep redbird herd in Hell's Canyon that we'll be working on through this module. I'm actually going to make a change there. I'm going to make it, see, I just double clicked on the symbol there. I'm going to change it to hollow so I can see what's behind it and make it a little thicker. Maybe I'll even make it a 2. Okay, so there we have the herd boundary. We have lakes. I can click those off for now. Let's look at the state polygons. We have Idaho here, Washington State, and Oregon State here. I'm actually going to make that hollow as well. We can make the state boundaries a little thicker too, maybe a different color. Make them purple. Okay, we have the DEM, National Elevation Data Set. Turn it off for now. And we have the NLCD, the National Land Cover Data. Let's go ahead and open that real quick. Just the attribute table. I just right-clicked on NLCD, said Open Attribute Table. I'll show you a couple of things there. So we have several different land cover types. Those are the values. They are just represented by a numeric code, but I have a table that tells you what they actually are. And then we have the count for each land cover type. For example, this land cover type 32 has 310 pixels, and each pixel in the data set, let's take a look at that as well. We can look at the properties for the data layer, and if we look at the, let's see, under source, I guess it is, we can see that the cell size is 30 by 30 meters, and it also says that in your lab document. So knowing that each pixel is 30 by 30 meter, we can figure out how large that data set is, or how much area there is of each land cover type. Anyway, so we'll continue. The next thing we're going to do, I'm going to turn this layer off as well. The first thing we're going to do is to clip out the area that's actually within the herd boundary for the digital elevation model. And the first thing you need to do in order to do that is to create a mask for that herd boundary. So we're going to start up Arc Toolbox, which is located up here. Looks like a little red toolbox. We are going to look at the Spatial Analyst tools. And we are going to look at, actually, the first thing we have to do is to convert this herd boundary from a polygon data set to a raster data set. So we'll go into conversions to raster, and we're going to go for a polygon to raster. These tools are all pretty easy to use. The input feature is the herd boundary. You can just drag it in there. And the field is, we can really use about anything. We can use doesn't really matter which one. There's just one row in that data set anyway. and then we can save the data set. I'm going to save all my data sets in a folder that's, I'm going to save it in my temp folder, but you can save it in whichever folder you want. Make sure you save it in a place that you know where it's located and you can use it later. So I'm going to go ahead and save it there. I'm going to call it let's just call that mask. And cell size should be 30 since all the data we are working in have 30-meter cell size. And go ahead and run that analysis. Okay, so what happened there was that this polygon layer was converted to a mask, or we created a mask from it. And here's the mask layer, which is simply a raster with the same exact outline as this herd boundary. I'm going to change the color scheme on that digital elevation model so we can see it a little better. I just double clicked on NEDDEM, go to symbology, and pick another color scheme. There we go. So I have my mask. Well, I had my boundary. I made my mask, which is a raster of the same size as that outline. And now I'm going to use ARC Toolbox again and the spatial analysis tools to extract the elevation layer for within that study area. So go to spatial analysis tools, go to extraction, and go to extract by mask. And the input raster is my NEDDEM, and my mask is mask. And I will save the data set wherever you want to save it. And we can call that herd underscore DEM. And go ahead and save that and run that analysis. Okay, so I'm going to close Toolbox, and here we have the digital elevation model clipped to the boundary of the herd boundary, and that's the herd boundary for the bighorn sheep in Hell's Canyon, in case I forgot to say that. So we can turn off that large digital elevation model, go back into my color changing deal here. Let's go for a brown, and there we have it. So now we have a digital elevation model where each pixel represents an elevation value at that particular location. For example, we can use the identify feature, this eye, to see what the elevation is at any particular location. I got to change that to my herd DEM. So for example, right there where I clicked, the pixel value is 527. That's in meters. This data set is elevation in meters. Anyway, so the next step in your lab exercise is step B, where we're going to look at surface analysis, and from this digital elevation model we can derive slope and aspect and contours and so on. So we're going to go back into our ARC Toolbox again, and we are going to look at, let's see, the surface analysis tools. So we'll open up those, and the first one we're going to do is aspect, and the input layer is herd DEM, and the output layer I will call herd aspect, or herd, maybe herd aspect. Go ahead and save that. Alright, so there is our aspect layer. I'm going to close the toolbox again. Maybe zoom in a little bit so you can see the aspects better. and that is the direction in which the slope is facing. So on a north facing aspect is facing, the sun is coming from the north, shining on that area for the north. Or another way to think of it is that if you poured water or some other liquid on the ground, which direction would that liquid flow? So we have north, northeast, and so on. If you try to open the attribute table for this layer, you are going to see that there is none. And that's because this layer is what you call a floating point layer, and we can look at that in the properties, see if it actually tells you that it does. So under the source tab in the layer properties, you can see that the pixel type is floating point. That means that these are built of decimal numbers, and of course there would be an infinite amount of numbers in the attribute table, so therefore there is no attribute table. The numbers go from flat is -1, and then from 0 to 360 degrees azimuth for the aspects. So you can continue and follow along in the lab document and derive your contours, hillshade, and slope, and then we'll look at the next demo for the reclassification. So that's the end of this first step of step A, B, and the next one will be C.